Okay, so here's a deck of flashcards to take you through C2.2. Okay, so the second topic in additional science, additional chemistry. Okay, structure, properties, and uses. Okay, just to remind you then, this is my YouTube page, One Page Science. This is GCSE, chemistry, AQA exam board, and C2. And if you're doing the combined sciences, this is in C2a. Okay, quick fire, let's go. Okay, so do simple molecules have high or low melting and boiling points? Answer, low. What state do simple molecules exist in at room temperature? Okay, they can be solids, liquids, or gases, but generally they are gases. Why is it then that simple molecules have low melting and boiling points? Okay, this is because they have weak forces between the molecules. Okay, these are called intermolecular forces, which means only a small amount of energy is needed to break those bonds. Why do simple molecules not conduct electricity? Because they have no overall electrical charge. Why do ionic compounds, do ionic compounds have high or low melting points? The answer is high. Okay, so next one. Why do ionic compounds have high melting points? Okay, because they have a giant ionic lattice. They have strong electrostatic forces between oppositely charged ions, which means that lots of energy is needed to break up those bonds. Okay, why do solid ionic compounds not conduct electricity? Okay, it's because the ions are not free to move. Okay, so if you melt or dissolve a solid that's an ionic solid, it will conduct electricity. Okay, so why? Okay, so because the ions are now free to move, and therefore they can carry the current or carry the charge through the solution of the system. Okay, why do macromolecules have high melting points? Okay, so this is because they are what's described as a giant covalent lattice. Okay, and all the bonds are linked together by strong covalent bonds. Okay, next one then, to explain why is diamond so hard. So, each carbon in diamond is bonded to every other carbon by 4 strong covalent bonds. Okay, and this forms a giant covalent structure, or a macromolecule. Okay, why is graphite soft and slippery? So, in graphite, each carbon bonds to 3 other carbons through strong covalent bonds, so that's the same as diamond. Right, but the difference here is that this forms layers which can slide over each other. Okay, the reason those layers can slide over each other is because there are weak intermolecular forces between the layers. So within the layer, the bonds are strong, but between the layers, the bonds are weak, which is why this word between is really important. Okay. Why does graphite conduct electricity when diamond doesn't? Okay, because it only forms 3 bonds. There's 1 spare electron in every carbon, which can be described as delocalized, and that electron can move through the whole structure. So it's a lot like a metal in terms of that spare electron. What are some of the uses of fullerenes? Okay, they can be used to deliver drugs in the body. They can be used as lubricants because they're slippery. They're often used as catalysts because they have high surface area. Okay, and they can be used in reinforcing materials like tennis rackets and bikes and things like that. Okay, what's the structure of fullerenes? How would you describe it? Okay, they're macromolecules and they're made up of hexagonal rings of carbon atoms. Okay, why do metals conduct heat and electricity? Okay, so metals contain a delocalized electron, and that electron can move through the whole structure. And when it does that, it can carry the charge and it can carry energy with it. Why are metals easily bent and shaped? Okay, this is because in a metal, the atoms are arranged in layers, and those layers can slide over each other. Next one. What is an alloy? This is actually from C1, but it's a good reminder. Okay, an alloy is a mixture of a metal and another element, and it's usually another metal. Okay, so iron and carbon, okay, is an alloy called steel. Okay, iron's the metal, the other element is carbon. Why are alloys usually harder than pure metals? Okay, so here, because you've got atoms that are of different sizes, it's less easy for the layers to slide over each other. Okay, so when you try and bend it, the layers can't slide over each other, so it makes it a harder material. Okay, what is a shape memory alloy? Okay, it's a material that will return to its original shape when it's been deformed. Okay, so you change its shape, and eventually it will go back to its original shape. One example of this is a material called nitinol, which is used in dental braces. How do you make low density polyethylene, LDPE? Okay, you need a reasonably high temperature, 200 degrees C, and a high pressure. How do you make high density polyethylene, or HDPE? You need a lower temperature, a lower pressure, and you use a catalyst. Why do thermosoftening polymers melt easily? So a thermosoftening polymer is one that will melt easily. Why is that? Okay, so a little diagram here to help you. You've got lots of individual chains, and they're all tangled up together. Okay, so individual chains are tangled, and between each one of these chains, there's only weak intermolecular forces between the chains. Okay, there's no strong bonds joining these chains together. Okay, why do thermosetting polymers not melt easily? Okay, so thermosoftening do melt easily, thermosetting don't. Okay. The reason for that is again, the diagram. Okay, so here the individual chains are this time not as tangled up; they're neatly arranged, but between each layer there are these bonds. Okay, so you've got the individual chains, and they're held together by what are called cross links. Okay, and usually these are strong covalent bonds. So this is almost getting into the realms of being what's called a macromolecule. Okay, you have these strong bonds between the layers. Okay, what is a nanoparticle or nanoscience? Okay, so structures or science that's done on the nanometer scale. So anything from 1 to 100 nm is shorthand for nanometer. What are some of the features of nanoparticles? Okay, is that they have different properties to the same material if it wasn't in a nanoparticle form, and that can be things like different colour, different strength. Okay, and something that affects the chemistry that they do is that they have a really high surface area to volume ratio because the particles are so small. Okay, the surface area to volume ratio is massive. Okay, what are some of the uses of nanoscience? Okay, all sorts of things. You don't need to know anything specifically, but this is just to sort of give you an idea. Exam questions will throw things at you, so they can be used in computer equipment, catalysts, sensors, coating materials, cosmetics, sun creams, making materials that are both light and strong. Okay, and they're really often really good electrical conductors. Okay, cool. So that's everything you need for C2.2 done. Okay, don't forget to subscribe, like, comment. Good luck with your exams, guys.